Now that we understand the machine learning pipeline and development practices, the next important step is selecting a programming environment for implementing machine learning models. Among many programming languages available today, Python has become the dominant language for machine learning and data science. Python is widely used because it combines several important advantages. First, Python has a very simple and readable syntax. Unlike many programming languages that require complex structures, Python code often resembles plain English. This simplicity allows researchers, engineers, and even beginners to focus more on the problem itself rather than the programming syntax. Secondly, Python has an extensive ecosystem of scientific libraries. These libraries provide powerful tools for numerical computation, data manipulation, visualization, machine learning, and deep learning. Without these libraries, implementing machine learning algorithms from scratch would be extremely difficult. Thirdly, Python is supported by a large global community. Thousands of developers and researchers contribute to open source libraries. This means that new tools and techniques are constantly being developed and shared. Another important advantage is that Python integrates easily with other technologies such as cloud computing platforms, big data systems, and web applications. This makes Python ideal not only for research but also for production level machine learning systems. Because of these advantages, Python has become the standard language used by companies such as Google, Facebook, Amazon, and Netflix for many machine learning development. While Python itself is powerful, its true strength lies in the libraries that support machine learning and data science. Several libraries from the foundation of the Python machine learning ecosystem are very important for us. Now, let us examine the most essential ones. The first library is NumPy. NumPy stands for Numerical Python. It provides efficient tool for performing mathematical operations on large arrays and matrices. In machine learning, datasets are often represented as matrices, where rows represent observations and columns represent features. NumPy allows us to perform operations on these matrices extremely efficiently. For example, vector operations, matrix multiplication, and statistical computations can be performed using NumPy. The second important library is Pandas. Pandas is used for data manipulation and analysis. It provides a powerful data structure called a data frame, which allows us to work with tabular datasets similar to spreadsheets or SQL tables. Using Pandas, we can easily load datasets, clean data, filter records, perform aggregations, or transform variables. The third library is Matplotlib. Matplotlib is a visualization library used for creating graphs and charts. Visualizing data is extremely important because it helps us understand patterns and trends in datasets. Common visualizations include line plots, scatter plots, bar charts, and histograms. These visualizations help identify relationships between variables before training models. Finally, we have scikit-learn. Scikit-learn is one of the most widely used machine learning libraries in Python. It provides ready-to-use implementations of many algorithms, including linear regression, logistic regression, decision trees, support vector machines, and clustering algorithms. Scikit-learn also provides tools for model evaluation, feature selection, and preprocessing, which makes it extremely useful for building machine learning pipelines. Let us now take a closer look at NumPy, which is the foundation of numerical computing in Python. NumPy introduced a powerful data structure called the NumPy array. A NumPy array is similar to a list in Python, but it is optimized for numerical computations. Unlike regular Python lists, NumPy arrays allows us to perform mathematical operations on entire datasets efficiently. For example, suppose we have a dataset containing thousands of numerical values. If we want to multiply every value by 2 using traditional loops, that would be slow. However, with NumPy, we can perform this operation instantly using vectorized operations. This capability makes NumPy extremely efficient for machine learning tasks. Another important concept in NumPy is array indexing. Indexing allows us to access specific elements or subsets of data within an array. For example, if we have a dataset stored as a matrix, we can easily retrieve a specific row, a specific column, a subset of values using slicing operations. NumPy also supports multi-dimensional arrays, which are essential for representing machine learning datasets. For example, a dataset containing 1000 observations and 10 features can be represented as a 1000 into 10 matrix. This matrix representation allows machine learning algorithms to process large datasets efficiently. Because of its speed and efficiency, NumPy is often considered the core numerical engine behind most Python machine learning libraries. While NumPy is excellent for numerical computations, Pandas is designed specifically for working with structured datasets. The most important data structure in Pandas is the data frame. A data frame is similar to a spreadsheet or database table. It contains rows and columns where each column represents a feature or variable. For example, a data set about houses might contain columns such as price, size, number of bedrooms, locations, and year built. Each row represents one house. Using Pandas, we can easily load datasets from files such as CSV files, Excel spreadsheets, or SQL databases. One of the Once the dataset is loaded, Pandas provides powerful tools for data cleaning. For example, real-world datasets often contain missing values. Pandas allows us to detect missing values, replace missing values, or remove incomplete rows. Another powerful capability of Pandas is data transformation. We can create new variables by combining existing ones. For example, calculating price per square meter from house price and house size. Panda also supports aggregation operations. For example, we might compute average salary by department, or total sales by region, or median income by age group. These operations allows us to explore and understand the dataset before applying machine learning algorithms. One of the most important steps in data analysis is visualizing the data. Before training machine learning models, it is essential to explore the dataset visually. Visualization helps us detect patterns, trends, correlations, and anomalies. The Python library matplotlib provides powerful tools for creating those data visualizations. One of the most common visualization types is the line plot. Line plots are used to visualize changes over time. For example, stock prices over several months or temperature variations during the year. Another common visualization is the scatter plot. Scatter plots show the relationship between two variables. For example, house size versus house price. If the scatter plot shows a clear upward trend, this suggests that larger houses tend to have higher prices. Another important visualization is the bar chart. Bar charts are used to compare quantities across categories. For example, comparing sales across different regions. Matplotlib also allows us to customize visualization by adding labels, titles, legends, or colors. These enhancements make the visualizations easier to interpret. By visualizing data before modeling, we gain valuable insights that help guide the machine learning process. The final step before building machine learning models is setting up the development environment. A proper environment ensures that all required tools and libraries are installed and functioning correctly. The first step is installing Python. Python is a programming language used to write machine learning code. Although Python can be installed directly, most data scientists prefer using the Anaconda distribution. Anaconda is a comprehensive platform that includes Python, package management tools, scientific libraries, and development environments. After installing Anaconda, the next step is installing essential machine learning libraries such as NumPy, Pandas, Matplotlib, and scikit-learn. Anaconda makes this process easy by providing pre-configured packages. Another important tool is Jupyter Notebook. Jupyter Notebook allows developers to write code, run experiments, and display results in an interactive environment. It is widely used in machine learning because it allows researchers to combine code, visualizations, and explanations within a single document. The final step is verifying the environment setup. This typically involves running a small test program to confirm that all libraries are installed correctly. For example, importing libraries and performing single computations. Once the environment is set up successfully, we are ready to start building machine learning models. And that's all for this video.